Hello friends, I am Dr. Tarannum Akhtar. I am Head Department of Physics at KME Society's GM Women Women's College Bhiwandi. My topic for today's discussion is thermodynamics, which is Bridge Course Module 1A to SYBSc Physics students. These are the topics which I'll be covering during my presentation. First, we need to understand the meaning of thermodynamics. It's a branch of physical science that deals with the relations between the heat and other forms of energy, such as mechanical, electrical, or chemical energy, and the relationships between all forms of energy. The first law of thermodynamics says that du is equal to dq minus w, where q is the heat supplied to the working system, forming a system, and w is the work done by the system. Then du represents the increase in internal energy of the system. The various thermodynamic processes are adiabatic process, isobaric process, isochoric process, and isothermal process. If no heat enters or leaves the system during some process, then it is said to be perfectly isolated from the environment, and it is a process called as adiabatic change. For this change, dq is equal to 0, and according to first law of thermodynamics, we can write it as du is equal to minus w. The next process is isothermal. If the temperature of the system does not change during a process, then it is said to be isothermal. And according to first law of thermodynamics, the heat absorbed by the system must be equal to work done, as there is no change in internal energy of the system. That means du is equal to 0 and dq is equal to w. The next process is isochoric process, the process in which the volume of the system does not change. That means dq is equal to du according to first law of thermodynamics. The next process is isobaric process, in which pressure of the system remains constant. There is a situation called as thermal equilibrium. This causes a temperature drop in the body A and increase in the temperature of body B. As we can see in diagram, there are two bodies. The body A is at higher temperature and body B is at lower temperature. They are kept in the same environment, so there will be exchange of heat from both the bodies, and this exchange will be continued till the situation of thermal equilibrium is reached. We have the concept of heat engine in thermodynamics. A machine that converts heat into useful work is called as heat engine. There are various parts of heat engine, such as working substance, source of heat at higher temperature, and sink of heat at lower temperature. If we talk about the working of heat engine, it says that it absorbs the heat from the source, doesn't work, and rejects the remaining amount of heat to the sink. The complete chain through which working substance does the work and returns back to the original state from one cycle of operation. The net work done in the cycle is known as output of the engine, and heat absorbed by the working substance is the input. That's all from my side. Thank you very much.